You know when you're scrolling through your social media feed and it just keeps going? That endless stream of content feels a little bit like magic, but really, it's a masterclass in software design. Today, we're going to pull back the curtain and actually build the engine that powers it.
Right? That effortless feeling where new stuff just seems to appear right when you need it? That's the whole goal. But behind that incredibly simple experience is a huge engineering puzzle that we've got to solve.
So here's the core challenge. How do you deliver this massive, constantly growing set of data to a phone with limited memory and battery life? You can't just load everything at once. That would crash the app and, destroy your data plan. We need a much smarter way to do it.
So our mission is to build a reusable engine, a piece of core software that any developer can just plug into their app to get that amazing infinite scroll feature. We're essentially designing the brains behind the whole operation.
Okay, so where do we even begin? Well, the first and probably the most critical step is a shift in mindset. We're not building an app for regular users. We are building a tool for other developers.
This quote really gets to the heart of it. Our user isn't the person scrolling through photos. Nope. It's the developer who's building that photo app. So our user interface isn't what you see on the screen. It's the code itself. How easy is it to use? How flexible is it? That becomes our new definition of a great user experience.
So, what does this developer user of ours really need? Well, they need ultimate flexibility. Our engine has to work with any kind of data. We're talking photos, messages, products, you name it. It needs to be able to pull that data from the internet or right from the phone's local storage. And on top of all that, it has to be incredibly fast, super reliable, and easy to use. That is a tall order.
Okay, so to give developers all that power and control, we need to design the main interface for our engine. In the world of software, we call this the public API, which stands for Application Programming Interface.
The best way to think of an API is like a restaurant menu. You don't need to know how the chef is cooking the meal in the kitchen, right? You just need to know what you can order and what you're going to get. A great API is just like that. It gives developers all the options they need without forcing them to understand every single little detail happening behind the scenes.
At the very core of our API is a component we're calling the Paginator. We're designing it with a really powerful concept called generics. Now think of generics like a universal container. We honestly don't care if you put photos, messages, or product listings inside of it. This Paginator is built to handle any type of data. This one decision is what makes our engine so incredibly versatile.
Our API is also super flexible in how it gets that data. Some apps use simple page numbers, like, hey, get me page 5. But others, especially those real-time feeds, use something called a token, which basically means get me everything after this specific post. Our Paginator is designed to handle both of these methods with the same simple command, giving the developer maximum choice.
We've designed the control panel. Now it's time to pop the hood and take a look at the architecture of the engine itself. This is really where all the performance magic happens.
The secret to a fast, buttery smooth experience is caching, and our engine uses two different types. The in-memory cache is kind of like your brain's short-term memory. It's super fast for things you just saw. The disk cache, on the other hand, is more like a long-term filing cabinet. It's a bit slower, but it remembers things even if you close and reopen the app.
So here's how every data request works, and the order here is absolutely critical for performance. First, the engine checks that lightning-fast in-memory cache. If the data's not there, it checks the disk cache. And only as a last resort does it go out to the network to fetch brand new data. This cache-first strategy makes sure we only do the slowest work when we absolutely have to.
Now, to keep this whole complex system organized, we break it down into specialized parts. The scheduler is our air traffic controller. It manages all the incoming data requests to prevent collisions and make sure everything runs smoothly. And then we have the evictor. It's like our librarian, cleaning out old, stale data from the caches to make sure they stay fast and don't eat up all the phone's memory.
You know, a good design on paper is one thing, but a truly great library has to handle the messy reality of the real world. And that means we have to anticipate problems before they even happen.
For example, what happens if you're scrolling down a feed really fast, creating new requests, while the app is also trying to prefetch some data in the background? All of a sudden, you've got competing requests for that same network connection. What do you do?
The solution is a priority system. The request that was triggered by your scroll gets marked high priority, and it jumps right to the front of the line. That background prefetch, it gets marked low priority. This simple trick makes the app feel incredibly responsive because it's always serving the user first.
And here's another classic real-world problem. You're in a tunnel, your Wi-Fi drops out. What should the app do? Just freeze up and crash? No way, absolutely not.
A really robust library anticipates this. Our engine has automatic retry logic built right in. So if a request fails, it'll just wait a moment and try again. And if it keeps failing, it reports a clear, detailed error back to the app developer so they can handle it gracefully, maybe by showing a little message to the user.
And finally, because other developers are going to build their entire apps on top of our code, we need to make a solid promise about how we release updates. We do this with something called semantic versioning. It's basically a simple numbering system that tells a developer exactly what to expect at a glance. A patch release? Oh, that's just bug fixes. Totally safe to update. A minor release? New features, but nothing will break. But a major release, that's a heads up that they'll probably need to change some of their code. This system builds trust and predictability.
And just like that, our engine is complete. We've designed a super flexible API for developers, a really smart dual cache system for speed, and a robust architecture that's ready for all the messy problems of the real world. This is the invisible workhorse that powers that endless scroll.
And that kind of makes you wonder, doesn't it? Every single time you tap, swipe, or pinch on your screen, there are these elegant, sophisticated systems just like this one working tirelessly behind the scenes. What other invisible engines are hiding in plain sight, making your digital life possible?